I think we are good to go. Hello, everybody. Thank goodness we do not have a full house because I'm nervous, and as usual, I didn't prepare. So we're just going to see how this goes. If things break, then so be it, but we're here to have a good time. If you want to stop me and ask a question at some point, I don't know, feel free to raise your hand. Let's just try to keep this casual, I like having conversations, and, it takes the edge off a little bit. I guess I should start by introducing myself. My name is Dan Salvato. I am a professional game developer, I guess you could say. Best known for a game that I released in 2017. It was a psychological horror game called Doki Doki Literature Club. The popularity of that game sort of launched me headfirst into this career as a game developer. So now I'm working on a few things, most of which are under wraps, but I have this, started as a side project and has become something much bigger since then. A game that I've been working on for the Amiga. It's called Magicore Anomala, and that's what I'm going to be showing off today a little bit, talking about a lot of the tools and the process that I go through in making this game, with the understanding that through simply better tools that we have now, as well as access to knowledge and all that, but largely through the tools, we can do things on this old hardware that even through no crazy tricks or wizardry or like the stuff you see in the demo scene, with none of that, you can still pull things off that are surprisingly modern and in many ways would have been impossible back in the day, given that they didn't have access to the tools that we did. So I'm going to start off just by playing through this demo that I put together for AmiWest 2024 last year to give you an idea of just the gameplay and the flow. I'll do that. I'll talk a little bit more about my background as well. Here we go. And okay, let me move my. Okay, I lied. I have like 5 bullet points on here, so I prepared a little bit. But I guess I should talk a little bit about my history with Amiga. I am a huge Amiga fanboy. It's like my #1 interest in the retro computing world. It was my family's first computer. So I first used it probably when I was like 2 years old, and eventually they got a Gateway Windows 95 machine a few years later. But even as a little kid, I wanted to bring the Amiga back out. It was, I couldn't tell you why. I was just very fond of it. I think it's because I think retro machines, they all have a unique personality, just based on the chipset, different graphics capabilities, different sound capabilities, and that becomes apparent just through the games that you play on them and the way that you use it. They have a personality, and you develop a fondness for that. I was too young to feel nostalgia, I think I was fond of the personality. And so I never lost that. I was always enamored by the Amiga, and as I got older and learned about just the incredible hardware that is inside this thing and what it's really capable of, I think that love only grew. And by the time I was a teenager, I decided that one day I would like to make a game for Amiga. And fast forward, 15 years, and suddenly I find myself with the skills to be able to do so. So I'm fulfilling a lifelong dream by making this game. And when I'm making this game, it's one thing to say that it's a game that runs on the Amiga, but I like to claim that this is truly an Amiga game. And what I mean by that is all of the aspects of this game, the game design, the gameplay, the mechanics, a lot of the progression, I came up with all of this based on my understanding of the capabilities of the Amiga. The Amiga started first, and I built a game around it, which is not necessarily something that developers were doing back in the day. I guess because they were a lot more concerned with, well, they had to make a living. Thankfully, this is a hobby project, so I get to do whatever I want. But I'm just going to kind of skip through the dialogue here. but I wanted to think about the Amiga's really unique and powerful capabilities in graphics to design a game that really capitalized on that. The Amiga's graphics system is special because instead of each pixel being like its own unit, Amiga works using bit planes, which means there are actually several planes layered on top of each other in order to get the final pixel. And so, although it looks like one coherent image, we actually have a bunch of separate layers kind of stacked on top of each other. And those layers are very, very tiny. Each pixel on one of those layers is just a single bit. You either flip it on or off. What that means is that you can manipulate that data extremely quickly, especially with the Amiga's blitter. The blitter is effectively like a rudimentary GPU that can copy and manipulate and clear data extraordinarily quickly, and that's kind of one of Amiga's many claims to fame. And you're going to see a demonstration of that in a moment and get a real idea of what this game is all about. Once I finish skipping through the dialogue here. And how's the audio level? Is it coming through well back in the audience? All right, cool, cool. By the way, this is stock Amiga 500, fully stock. 7 megahertz Motorola 68000 CPU. It does have the trapdoor memory expansion, but I just want to make a point that I'm targeting the stock hardware because that's what a lot of people consider as kind of like the games machine. And now you're going to start to see things kind of really shine with this game engine. With the amount of objects I can draw and animate on the screen and retain a full 60 frames per second. I think it's lagging a little bit because of the video output, but yeah, this runs full of 60 frames per second. There's not a single frame of lag during these attacks. And give or take, I can draw up to, I would say, 200 bullets on the screen and maintain a full 60 frames per second. So what I'm effectively have the opportunity to do is create sort of like a demo scene, a playable kind of demo scene experience. That's what people have compared this to, is some neat little demo scene effects. It's not quite on their level. Like, the demo scene is absolutely wild, but their point is to do things that literally appear to be impossible on the target hardware. But my point is to do everything that's possible. In fact, what the hardware was specifically designed for. I would say that everything in this game is taking advantage of components of the hardware that it was literally just designed to do on paper. And this one's pretty cool. So I would say I've been working on this game for about 3 years now, specifically the game engine and all of the tooling around it. It's 100% coded in assembly language, and we just started full production of the game in May. So there's a whole team of people working on this at this point, creating all the final content now that the game engine is mostly done. And we're hoping to release it, I don't know, maybe a year and a half from now. We're going to release it on Steam, hopefully other platforms as well. It's going to be, sort of transparently wrapped in an emulator. And of course, you can grab a disc and run it natively on your stock Amiga 500 as well. And let me just, oh, I didn't show off the death animation. I'll show you what it looks like when you die. Pretty cool, right? Okay. Oh, and it sends you back one attack too, so I'm just got to finish this up once again, get to the ending. But, yeah, let me see. Okay. And I would love to go into kind of the inner workings of this game engine, and I'll probably talk about that a little bit, but we're going to focus mostly today on the tooling. I want to show you how, what the development workflow looks like, how everything that I do is using modern tools and kind of the incredible capabilities that these tools can unlock, which some amazing members of the community have prepared and made them really easy and accessible to use, so that anyone can sort of just get an extension for VS Code, and it sets up a dev environment for you and a little demo program, and you just get going right away. It's really amazing. how easy they've made it at this point. My dev environment's going to be a little more complicated than that because I've been iterating on it for like 3 years now. But I just wanted to make a point about how easy it is to get into this. And that is my AmiOS 2024 demo of Magicore Anomala. And there's my one death, which is on the record that I took on purpose. Okay, let's quit out of this a little bit and get to the juicy stuff. Let me see. Let's make this a little bigger. Okay. Before I jump into like all the stuff I have going on here, if anyone has any like initial questions about the stuff that they're saying, then you're welcome to you're welcome to like raise your hand and ask any questions. But yeah, go ahead.
This is mostly a joke, but will you be able to collect melons?
I don't know if there's like a single other person in this room who would understand that joke, but no, not melons, but there will be collectibles. There will be. Okay. This is my development environment. So I personally use NeoVim for development. Is this large enough? Is this like readable enough? It's not like we have to read all the individual text, but yeah, I use NeoVim for my environment. And just to show you, let me start up the emulator here as well. Get this going. I use WinUAE, which you'll notice I'm on Mac OS. I use WinUAE wrapped in wine, actually, for a couple of reasons which I'll get into. But yeah, let's just go ahead and let me make sure the parameters are correct here. Yeah, I think we're good. So I'm in my dev environment, and let's say I'm like working on some gameplay. So I'm going to jump in and test this couple rooms that I'm working on. As you can see, the graphics aren't done here yet, largely focused on, we make the gameplay and graphics kind of separately. Did things just freeze up already? Yes, they did. What? I told you I wasn't prepared. All right, give me a sec. Let's see if I can figure out what's going on. I'm at least a little bit prepared. I did a lot of testing before this, and what do you know? Things are already not working. Let's see. We good now? Yeah, there we go. Okay. I don't know. The game was freezing up for some reason, but yeah, we should be good now. So yeah, I was working on some gameplay here. And here's me navigating through these rooms. Just to give you a little bit of context, yeah, this is one of the chapters in the game. This is kind of the platforming section of the chapter, and there's this gimmick where when you collect those little glowing diamonds, you get one of your jumps back. So you have 3 jumps, and you can't make this jump normally, but as I collect them, I get them back. It's kind of like a precision platformer sort of game, so I can navigate through like that. But the first thing I want to show off here is how staggeringly fast I can make changes and get back into the gameplay. So that's me compiling the game and starting it up. Let me change a parameter, compile the game, and start it up. There we are in this room. And anytime I can hit this button to reboot the machine, that is a complete reboot, a cold reboot of the entire Amiga, right there, booting back into the game. The reason that is possible is, well, there's a couple things going on. The first thing is when I reboot the machine, it is booting into the fastest possible CPU, a Motorola 68060 configuration for the Amiga, and I'm also uncapping all frame rate limits so that there's, all stops are pulled, and it just blazes through all of the startup as fast as humanly possible. And then as soon as the game finishes loading, my game sends a command to the emulator, which is an amazing thing about WinUAE. You can write to certain memory addresses in your software to talk to the emulator. So when my game finishes loading, I write to the emulator and swap out the CPU with a stock 68,000 when my game is finished loading, which is something that, of course, only emulators can do. But that's how I'm achieving, in a very simple way, this incredibly fast boot cycle on the machine that allows me to make these tests and changes incredibly quickly. So that's kind of the first thing that I want to talk about here is the iteration process when we're designing these games. If you want to make a good game, you have to go through a lot of iteration. If you've attempted or you do game design, then you're oftentimes making these tiny meticulous changes over and over and over again in order to get the gameplay that you're looking for. For example, these little jump refreshers, as I call them, maybe I decided that, well, maybe I want that one to be a little bit higher, a little bit lower. Maybe it's like I don't want to have to jump so high to get it, so I'll probably want to go in here and change a little parameter. This should be the height for the first jump refresher, so let's go ahead and lower that a little bit. I don't know. Again, the entire game is compiling and coming back in, and now it's a little bit lower. And now I can get it in 2 jumps instead of 3. So it's that fast and easy to make changes and test them over and over, and that's a large part of how this sort of gameplay is possible. I think back in the day, it could take minutes to test each iteration depending on how your tools are, and then the game's going to be crashing and the system's going to be crashing and you have to do the cold reboot and it's going to be a whole process. But with a cycle like this, yeah, we can make some really good games a lot faster. It also helps that I don't have deadlines, by the way. That also leads to good games. Being able to actually finish the game before you release it. So just want to mention that as well. But that's the first thing I wanted to mention is the iteration process. And I think to go along with that, another really important part of game design tends to be, of course, not just the engine itself and coding the game, but it's going to be the tooling around how to create the content for the game. That's really important as well, and that's one of the stronger benefits that these modern game engines like Godot and Unity and Unreal offer us is they have so much extensible tooling built in that you don't have to write nearly as much as your own custom software to build your maps and process your assets and stuff like that. These engines have a lot of that stuff built in. I didn't have that luxury because I built an engine from scratch in freaking assembly language, so that means I have to build all the tools too. With a few exceptions. For example, we use a lot of Ace Sprite for the levels at this point. And I do have the build tools to compile these, but this is the level that I was just playing. You can see it represented here in Ace Sprite. And I can very easily adjust the tile set. Let's go ahead and, I don't know, let's just have a little bit of fun. We'll erase the tile there and we'll put a little platform there. And maybe I want to make this section a little more difficult in some way. So I'll go ahead and put some spikes along this wall. Like that. I don't know. It doesn't really make it more difficult for this kind of jump. Maybe if I stick one here, it'll be a little more difficult. And these don't have to be spikes, by the way. This hazards layer is just a full-on bitmap image. And we're going to talk about that a little bit later. But I'm just going to go ahead and I'll go ahead and export this, jump back in, and we build. And there are my changes that fast. Just in a matter of seconds, I can just quickly jump into Ace Sprite, change a few things, and test them out right here. Incredibly fast iteration process, which, again, this is like a precision platformer and bullet hell game, so that sort of iteration is extremely important. The kind of back end of the way this build process is made possible in the first place, because Ace Sprite is just images, right? Ace Sprite, it's a pixel art painting program. I guess if I wanted cool points, I would be using Deluxe Paint here, but I'm using Ace Sprite. And I'm just exporting this as an image file, basically, which means that there has to be something in the back end that takes the data from the image file and understands how to kind of compile it into an actual playable level with tiles and collision and all of that. And that is largely done through a framework that I built. It's not just for these maps and levels, it's actually for compiling all of the data in this game. And the framework is open source, by the way. It's called Build-A-File. And it is written in Python. I'm a fan of Python. And what Build-A-File allows you to do is it allows you to design your own custom file formats, which is incredibly useful for making retro games, and I would say retro software in general, because you don't have the luxury of using PNGs and JSON files and and all of these other kind of big, bulky, higher-level constructs. You need to crunch this down into your own custom binary file format, and that's what I'm using Build-A-File for. Here's an example. Here is the data structure for a room, and I'm just defining it as a class in Python. And you can see all of the fields in this data structure. They are, signed 8-bit integers, unsigned 8-bit. Here's a couple 16 bits. Here's an array for the starting position. Here are the different sides you can exit on, and there's some default values as well. And this is the data structure that ultimately gets compiled into the game in this exact order. So what I've effectively made here is this self-documenting code that has the data structure in the same spot as the place that processes the data. So now I can go in, and there's this TOML file where I can specify, here's my list of rooms, for example. Let's see, I was just in that basement room. And I just give it an ID. There's the map, which is the PNG file that's coming out of ASprite. There's an event that runs when you enter the room, and here's one of the exits. And I'm using variable names for all this, but this is just an integer. That would be like, the next room ID that you go to, for example. And those fields, when I build the game, the values in these fields get piped directly into this data structure and get compiled into the game's eventual binary. I can also manipulate that data because, as I mentioned, for the map field, I'm just giving it a PNG, and that's not going directly into the game. And that's where you can use what I call setters, where for each of these fields, instead of it going straight into the field, you can put it through a pipeline first in order to process the data in some way. So that's all I have set up. I say, like, for the hazards, for instance, there's kind of an interception where it takes that data that I'm putting in, which is the file path to the PNG. It grabs that data, does some magic on it, and then outputs a tile map for my game, which is just a simple array which says the different tile IDs and stuff like that. Very easy and magical because Python has an amazing image processing library that very easily lets you take images and crop them and manipulate them and read the pixel colors and things like that. So yeah, I'm literally just taking this image coming out from ASprite, checking what colors the pixels are in order to determine what kind of platform it is. And then that just goes into an array into my game. And in the case of the hazards layer, well, that's actually just a straight bitmap that goes into my game, so I just have to convert it kind of into a format that Amiga understands. And that's what it's like to get these rooms into the game. But Build-A-File is kind of at the heart of all of the data that I'm processing, including music, for example. Is anyone familiar with ProTracker in here? Okay. How about tracker music in general? Who's familiar with tracker music? Okay. So you get the general idea. These machines can't play MP3s, You have to give them a set of instructions to tell the audio chip what to do in order to play your music. But are you going to write those instructions by hand? Probably not. So some clever people have invented software called trackers, which I have an example of one here. This is OpenMPT. This is not going to scale super well on that screen, but you don't really have to look too closely at it anyway. What this effectively lets you do is you can, hopefully the audio works fine here. Let me just test it real quick. Yeah, it's coming through. Okay. You can take a bank of instruments, you know, like I have a voice instrument, a bass, a kick, and some other stuff in here, like a bell instrument. And here's my 4 channels. The Amiga has 4 separate audio channels that you can be playing sounds on, and I can just go in and start keying in some notes. And I'll go ahead and delete that one. And once you're done keying in the notes, you hit play, and it just plays them in sequence through your set of patterns. So this is a track that I was working on. All right, I'll stop it there. You get the idea. Oh, and by the way, this track is only 3 audio channels, not 4, because one has to be reserved for sound effects. And I can tell you it is a pain to write audio that where you can only play 3 sounds at the same time. Pretty difficult, but I'm getting the hang of it and working with some really talented composers, and it's coming along well. But I made this track for my game, and the interesting thing about this is the samples that I have in here are kind of source quality samples. These are all like 48,000 hertz, 16-bit high quality samples. And if you don't know much about audio, the number of hertz is basically how much data are you packing into every second of that sample. And of course, we have modern technology, so we're packing a lot of data into a sound for every second of it to make sure we get high quality. Well, Amiga's audio chip can't get through the data that quickly. And so if you try to take like this modern sound and give it to the Amiga, it plays through it in slow motion because it can only go through it so fast. There's too much data here. So that means I can downsample it. You know, I can cut the sample rate in half in order to reduce the amount of data so that Amiga can play it at a reasonable speed. So I think there's like a resample thing here. And I can downsample it. You know, let's go pretty far down. And I'll play it again. Oh, it didn't make a change actually in the tone. Oh yeah, because I have like the root note transpose thing going on. But anyway, that's been the process for making a music for the Amiga for a long time. And it's this kind of balancing act because you want the Amiga to be able to play the sample. You know, you don't want that slow motion thing because there's too much data. But if you get rid of too much data, then your sample is really low quality, and it's going to sound like an underwater, like echoey, crunchy kind of sample. So what is the sweet spot where the Amiga can play it at like the maximum speed it can go, but then you're not actually losing quality by going under that. And as you can imagine, there's going to be some math involved. You got to take like the sample rate of your sample. You have to take the highest note that you're playing in your tracker file, because that matters too. It's like, are you going up to octave 5, octave 6? Like, how fast do you have to play it? And then the maximum sample rate the Amiga can handle and handle all that. It's terrible having to figure all that out. So I wrote a tool to do it, and it's part of my build tools. And so we can take a modern tracker format. In this case, well, it's not super modern. We're using Fast Tracker right now. It's at least more modern than Pro Tracker. You can give it these sort of source quality samples and key in the correct notes, and it's going to go through my build tools and automatically calculate for every single sample. It's going to virtually play through the song, check what is the highest note that's being played on every single sample, and kind of calculate that to be the maximum, downsample it so that that highest note is the maximum Amiga playback rate to make sure you're always getting maximum quality for every sample without accidentally overrunning it and getting slow motion playback. So I'm going to show you what this song sounds like in the game, if I can remember where to go for that. I think we have to go back to the first room, make sure like the boss test room is set up here, which it looks like it is. The event is correct. Let's check the definitions for the boss attacks here. Okay, I think that's all set up. Okay, let's go ahead and build and see if the boss fight successfully starts. That's the wrong attack, but that one's cool too. Okay. Let's see. I think I understand. Let's go to this file, go to event 63, and start that attack instead of initializing the boss fight right away. Again, extremely fast iteration to do this stuff. Sounds pretty good, right? Does that sound like an Amiga? Maybe a little bit, because if you're an Amiga fan, you know that it's illegal to make a game that doesn't have amazing music on the Amiga, right? So yeah, we're making sure to check that box. But we have this incredible workflow now where, again, instead of like doing this meticulous dancing and worrying about this technical aspect of every sample, I can just let the composers do their things, and my tool takes care of the rest. And we can take it a step further in certain ways. It's not something that I've implemented yet, but I can, for example, programmatically implement side chaining, which is a technique where when there's a big bass hit, like a kick, all of the other sounds duck in volume to make the bass sound louder, and it gives you this really thumping, like club kind of sound. And that is a pain to key in by hand, doing all those volume commands, like to create the volume ramping for every single sound every time there's a bass hit. I can do that programmatically now. I have control over the quality of each of the samples that I want, so I could say that you know, this is targeting maximum quality, but maybe there's a sample, it's a really big sample, and it's taking up a lot of RAM. I decide I can afford to lose some quality, so I could say, let's do this 75% max quality, and then I just save, I don't know, 40 kilobytes of RAM just by doing that. Again, my tool takes care of it automatically. So incredibly easy to control the parameters and taking advantage of these really rapid calculations that only modern machines can do. Putting them through these audio processors that, you know, downsample with maximum quality in 50 milliseconds for the entire set of samples. It's something we're really taking advantage of. And the second thing I'm taking advantage of is, let me just, let's see, what did I want to put? Here we go, let's put this up here. The other thing that I want to mention real quick, and it might just be an excuse to play this sequence again. This time I'll put a different attack to start the boss fight. I wanted to show this one off, but I accidentally bumped it down the list. Just one that I was working on recently, just kind of working on this sequence. And it's visually a little bit glitchy still, you know, I haven't hammered out all the technical details. But this image here is a pretty high quality image. The background is also a high quality image, as you can see. Pretty cool, right? All of these high quality assets, the images and sounds and everything, they take up a lot of RAM when we don't have that much of it. So I'm working with 1 megabyte of RAM. That's going to be 512K general purpose memory that only the CPU can access. So that's where you store your numbers and your data. Then the other 512K is what the other chips can access, the graphics and the audio and everything that actually goes out to your eyes and ears. So I think what a lot of older games used to do was, well, they have to make precious use of that 512K, but they can't be loading from the floppy disk all the time because that's really expensive. And so they end up making sacrifices in the quality of the graphics and the number of assets that they actually have in their game because they can only fit so much into RAM. I don't want to make those sorts of concessions, and today we don't have to because we have absolutely amazing compression algorithms that we did not have back in the day. There is one called ZX0. That's what I'm currently using. It is an offshoot of a modern LZ-based compression. And LZ goes way back, but it's also gotten a lot better. So I think it's an offshoot of LZ4, specifically designed for retro hardware. So most of my graphics data, all of the images and the sound effects as well, a lot of other data goes through this compression routine, which is really important because, for example, like these hazards layers, there's one of these for every single room just about, you know? And this is a full 320 by 180 bitmap image. Am I going to be storing that much data in the RAM? Of course not. But look how much empty space there is. Empty space just gets compressed away to literally nothing So just throw it through the compression algorithm, and it does a really incredible job at compressing this down to like probably 5% of its original size. And then when it comes time to load this room in the game, it unpacks it on the fly, because again, we have amazing compression algorithms that can also decompress really quickly. And I just get to enjoy the end result of going from room to room, which can have unique backgrounds, oh yeah, my little changes are still in here. Unique backgrounds, unique hazards, and everything else going on. And there's zero loading time to decompress those assets. It just takes me right into the next room. This algorithm, ZX0, is front-loaded on the compression side. It takes a really long time to compress data in exchange for really fast decompression. And when I say really long time, I mean like, I can give it a 100 kilobyte file, for example, and it'll take like, I don't know, 1 to 2 seconds to compress, which is a lot for that file size, you know what I mean? Out of curiosity, we had a community member take this compressor and compile it for Amiga, running on, I think I ran it on a 14 megahertz 68020. I gave it a 40 kilobyte file. It took an hour to compress. And it took 80 megabytes of RAM to compress, which obviously you were not able to do back then. So I think this is a great example. This incredible compression routine is allowing us to, in yet another way, achieve something that was actually impossible on the machine back then, leveraging our incredible computation to output a type of data that they would not have been able to achieve. And that gives us this incredible throughput, allows us to make maximum use of this RAM, and also decompress it extremely quickly without having to worry about loading times or anything like that. Let's see. What else do I want to show off? There's plenty of stuff I have. Here's a quick one. Since, you know, given the nature of this game and how many objects I have on screen, there's a lot of optimization when working on the different attacks and things like that. I can show the cycle timings just like that for every single instruction. The number of cycles it takes up, the number of times it reads memory, which is important on Amiga because it's kind of a shared memory access between all the chips. It's that easy, just built right in. This is a plugin that I was working on based on a similar one in VS Code. So again, if you're doing this in VS Code, you could just grab the extension that does this. Incredibly useful. I imagine back in the 80s and 90s, they were flipping through books to try to get this information when, you know, here we have it all listed out right on the instructions, and we can see exactly where the inefficiencies are in a given function that we work on. So that's a cute little one that I wanted to show you. Let's see. Another one I wanted to mention is, what room do we have it in here? I didn't test this scene beforehand, so let's see if this boots up fine and hope I don't, oh, that's not the one. It's probably this one. Right. So yeah, this is a scene that I was working on. The background is pretty colorful in these scenes. Backgrounds in this game have 8 colors. Just based on how I have the color distribution work. The background's 8 colors. The attacks are technically 8 colors. Not going to get into too much detail about the bit plane system, but I'm forced to allocate 8 colors to the attacks, even though it looks like 1. And then finally, the last 16 colors are reserved for the sprites. But I can tell you there's more than 8 colors happening here in the background. And that is through some additional magic that we have in the build tools. Let me see, maybe this scene is nice looking. Yeah, this one's pretty nice. That's clearly more than 8 colors, right? What we're actually doing is we are conforming not to 8 colors for the background, we are conforming to 8 colors per scan line of the background. Or not really per scan line, but we have like sort of regions, like little rectangles that are 8 colors each, because per scan line would result in a lot of color data. But the Amiga is really, really good at, in the middle of the screen being drawn, being given instructions to change the color palette, change I don't know, the screen pointers or memory. That's how the text box is being drawn. It's hardware split screen. You've seen very famously, like, you know, the Amiga workbench, you drag the workbench down and have like multiple, you know, apps behind it. It has hardware supported split screen. So I'm taking advantage of that by using the copper, the coprocessor, to say, you know, once you reach this scan line, swap out the color palette for something different. And that allows me to get these really colorful backgrounds when only 8 colors are allocated to them. And guess what? That is also very computationally heavy, because I could tell the artists, give me a list of all the scan lines and all the exact color palette information, and try to line up as much of those colors as possible so we don't have to swap out that many. They're not going to do that. If they were, then either I would go bankrupt or they wouldn't be working on this game. So I said, here's just loosely the rules you have to conform to. Give me the image. And I put it through Pillow, a Python image processing library, which, again, probably in a few milliseconds, splits up the entire image into 180 horizontal lines, looks at the colors on every single one of those lines, or quantizes it down to 8 if it finds more than 8, and then it warns me if it does that. And tries to compare to adjacent lines and group up the similar colors, and then output a table of where the differences are and what colors need to change at what indexes, and then puts that into my game as part of the level file. This happens in a few milliseconds, this crazy image manipulation. Once again, that would require hours and hours and hours of manual labor if we did not have this incredible computational power to leverage. Okay, let's see. Let's check out this attack that I was working on for the boss fight. Let's just throw that here and head back over to this event and start the boss fight right away. Jump in here. And oh, I forgot to change the room number back to the boss arena, so let's go ahead and do that real quick. Man, can you imagine just like this iteration process? Oh, that's the wrong attack. Just simple things, like I had to restart that like 3 times just because I forgot to flip a couple of variables. Can you imagine what this would be like if you didn't have this sort of system to produce a game like this? Okay, so this is an attack. It's not finished, but it's an attack that I was working on. Let me see, do I have invincibility turned on? Yeah, I do. Okay. A lot of times when I make these attacks, I try to find cool looking patterns, and I design those first, and then I go back in and I'm like, all right, how do I make this fun to play? And this is one example. I have these chains going across the screen. They're blinking in and out. That's something that I was testing, but they're kind of in the shape of a heart in the center, and I really liked that pattern. But there's a lot going on. Those chains they're pretty large to blit, and each chain link is its own bullet. So there's quite a few of them, right? And I had to kind of optimize the length of the chains and the distance and all of that in order to get good performance out of this. And that gives me an excuse to show off this console output. Again, I think it's pretty small. But this is the WinUAE console output. I mentioned earlier that you can use your game to send commands to the emulator, which is how I was hot swapping the CPU when my game finished loading. You can use it to print to the emulator's console, which is incredible for debugging. Just a very quick command to print strings to the console, and it's a printf, by the way, so you can give it any information you want about the game, you know, statistics, warnings, like what the game is doing, the amount of memory left, anything you want. And I just designed something where at the end of every frame, it checks to see how far down the frame it is when it finishes all the calculations, and if it starts to approach the bottom of the screen, if I start running out of frame time, it prints it out to the console. It says, hey, here's the a new longest frame that you have during your sequence, and it gives me the line number. So I can play out an attack or a sequence of attacks and look at the console, and it tells me what frame was the most expensive, like what's my maximum there. So I can optimize it and make sure that I'm not risking having frames of lag during any of the attacks. Incredibly useful for design and debugging, and something that would be quite difficult to do otherwise. In fact, on original hardware, they'd probably have, maybe they'd be outputting to a log or something, but that's more expensive, because then you're doing disk writes, and then if it crashes, you lose that information, or you have to fetch it in a debugger, or maybe serial output to another system. I'm not dealing with that. We have modern tools in order to take care of that stuff for us. Speaking of debugging, let's say, and I don't have an immediate example because my code is perfect, but not really. But let's say we have a bug, which I'm just kidding. Like 30 minutes before this talk, I was fixing bugs in the stuff that I'm trying to show you. But yeah, let's go back into the attack we were working on, and let's turn on debugging the level, build this real quick. Okay, here's our attack. Yeah, let's say something is crashing in here. And let's try to figure out what that is. Maybe it's the routine that spawns the bullets, right? So let's set a breakpoint, and let's launch the debugger. And we hit the breakpoint. And now we're stepping through code in the debugger. I can read memory live. Or I spelled it wrong, but yeah, I could read memory live. There's my X position. I can't take credit for writing this tool. This was some other incredible people in the community. There's, let's see, Graham Bates and Bartman and PRB28, who have made these incredible tools for modern IDEs and these debugging stacks that effectively they forked the Amiga emulator with remote debugger capabilities. So now you can use the standard debug adapter protocol that VS Code uses, and anything that supports it can just hook into the game, and you have a debugger right in your IDE. So you get all the benefits of your IDE alongside the debugger, and can use both in tandem, which is really incredible. Not to mention other IDE features like, documentation. There's comments right there. If I want to be reminded what a function does, like this gets a list from a list index. Especially, again, in freaking assembly when you have to worry about what registers you're using and passing around. It tells me which registers I need to load up. It tells me which registers it destroys when the function comes back, so I know to not keep any data in there before running the function. And I just have an incredibly fast and easy reference, or I can just instantaneously jump straight to the definition. If you code, you know this. You're doing this stuff all the time. So you know how it works. But the fact is that these are all incredibly modern tools that make us better coders, and is in fact changing the way that we code because we have such fast access to entire code base and documentation. We have new coding paradigms that are kind of designed around that. And that is something that we are now enabled to make use of when making retro games as well. Again, making the iteration process much, much faster. Guess what? I haven't been looking at the clock at all, and I have 3 minutes left. They did tell me that it's fine if we go over a little bit because I'm the last talk, because they wanted to put me at the end. But, I feel comfortable, we'll probably be able to stick around for a little bit and ask questions and all of that. I'm just going to quickly review this and make sure that there wasn't anything crazy that I didn't get to show off yet. But look at that. They increased the timer for me. Thank you, tech in the back. They gave me an extra 4 minutes. Okay. I guess the last thing, I went through most of the development stuff I wanted to go through. Real quick, I want to talk about, I guess, release plans for the game, because, hopefully if I did my job of being a game designer, you might be interested in picking this game up. Like I said, it's going to be on Steam. It's a while out. There's no wish list page or anything yet. I'm pretty low-key about this right now, just because we're so deep in development. But Steam is going to be kind of the #1 optimized platform for this game. It's in 16:9, for example, as opposed to 4:3. I'm using square pixels, which is strange for Amiga. It's an NTSC, where most Amiga games are in PAL, just because it provides the best experience on Steam. Not to mention, my audience tends to lean a little bit younger. Most of them have never even heard of Amiga. They don't care about it. So I can't lean on that as being a selling point of this game. It just has to be a good game. And that's why, and hopefully it's come through in what you've seen, I'm trying to make it really look and feel and play truly like a modern indie game. You don't even have to know it runs on, You might think it's a retro style game, but no one even has to know that it runs on actual retro hardware in order to just enjoy the game. So that's been a really fun and interesting challenge, and has encouraged me to build this engine and all the tools in the way that I have to provide that truly modern experience. So that's a little bit about the release plans, and I think that's all the major stuff that I wanted to go over. You know, there's a lot of technical engine stuff. I could talk about this forever, so please ask me about it. I guess for the time being, I can say thank you for coming out and listening, and I am happy to take some questions now. Thank you. All right.
Yeah, thank you. That was a wonderful talk.
Thank you.
And I love the fact that you're using modern computers to optimize for retro hardware. And I was wondering if this type of thing is happening not just with retro games, but other places. I'm thinking like there's satellites up there that have really old hardware. Can we update them to do more cooler things? Or maybe things on factory floors, or older car engine, you know, computers in cars or something. Are there other places people are taking modern computing to optimize for older retro hardware?
That's a really interesting question, and I would bet you that they are. I can't really answer that because I'm not doing anything that important. I'm making video games. But I have a hunch that the recent restoration of the Voyager spacecraft, after that went offline for a while, we had to have made use of some modern tools in order to make that possible. I don't know if we would have been able to pull something like that off 30, 40 years ago. You know, you're all going to speculate as much as I am, but yeah, that is a really good point, that there are so many industries and systems where retro tech is still being in use. I don't know, banks and insurance companies and airlines and aerospace, where I am sure that they're looking for these sorts of optimizations. In fact, I think it probably comes, a lot of it comes through virtualization, right? If you're able to replace the physical system with an emulator, well, now you can clock that emulator at 1,000 times the speed of the original system, and I bet you that there's going to be like a lot of, for example, database software that is making use of that extra power. Good question, though. Anyone else?
Hello. The game looks incredible. I'm
Thank you.
really looking forward to playing it.
Thank you.
But so does the toolkit. And I'm wondering if that's something you're planning on publishing at some point, just to allow other people to do the same thing that you're doing. You've already done a lot of this legwork, and so many other developers could probably benefit from it too.
A few things. The Amiga IDE sort of tools are already available. Like I said, there's VS Code extensions for that. My build system, which I called Build-A-File, that thing where I define the data structures in the Python classes, that framework's already open source and available to use. So if you're working on your own retro projects, please look into it. I need people to tell me how bad it is, basically, because I'm the only one who uses it right now, and I need people to stress test it and file bugs and stuff. And the tool that does the audio processing, like taking that fast tracker file and crunching it down into Amiga, that's open source as well. So I am open sourcing some of these tools. And down the line, maybe a bit after release, I plan on open sourcing my game engine as well, which is specific to my game. It's probably not going to be suitable for other types of games, but I want to open source it just because, as you're mentioning, I want other people to be able to benefit from my work in this way. So yeah, I appreciate your interest in that, and I can say that I'm putting an effort to make that happen.
Yeah, thank you, Dan. That was an incredible presentation. You said that you're going to release the game in Steam. Are we going to be able to use real Amiga as well?
Yeah. It will, of course, run on a real Amiga. Like I said, I'm targeting stock 500. In fact, I'm talking to people who want to make a boxed version of the game for Amiga. So that would be pretty dang cool if we could make that happen. But of course, if you buy the game in any form, you're going to get disk images, like both ADFs as well as just regular files that you can throw in your Amiga and just run.
That's great.
Anyone else?
Hi, thanks for your presentation. It's awesome. When it comes to retro gaming, I always prefer to play it on actual hardware rather than on emulation. I don't know if that's a psychosomatic thing, but as a developer, is there a difference, a real material difference between playing something or developing it and seeing it on emulation in an emulated environment versus the actual hardware?
It feels different. That's the best way to put it. It's probably a little bit of latency, a little bit of the audio-visual experience just being more analog on the real hardware. It feels different. And I'm with you. It feels so incredibly satisfying to play this game on real hardware. And I don't do it very often because my whole workflow is an emulator, but once I throw it on an Amiga and play it, it feels great. It makes me feel more proud of my work playing it on the real machine. And I will be overjoyed by people telling me that they experience it as well on their original hardware. Okay, we are out of time, but please run into me and ask me more technical stuff about the game engine, because I will talk your ear off about it, and I really appreciate everybody's interest. Thank you so much for coming out, and I'll see you around.